Hi everyone, this is Rohan, and in this video I am going to demonstrate how to find the deflections in trusses, that is pin jointed structures, using unit load method. Come, let's learn. So this is the problem that we are going to be dealing with today. A pin jointed structure or a truss is given here, where A is a roller support and E is a hinge support, and a vertically downward point load of 50 kilonewton is acting on the joint B, and the length of member AC and CE are given as 4 meters each, and the length of DE member is given as 6 meters. Moreover, the cross sectional areas of each member is given as 800 mm square, and the modulus of elasticity, that is E, of all members is given as 2 into 10 raised to the power 5 megapascal. And what is asked? We are asked to calculate the horizontal deflection at D, and we are supposed to use unit load method. Okay, so before I jump onto the problem, just check the indeterminacies of this structure. So just see that this is statically indeterminate structure, because the degree of static indeterminacy, both degree of external static indeterminacy and degree of internal static indeterminacy are 0. So therefore the total degree of static indeterminacy is 0. However, if we see the degree of kinematic indeterminacy, we will see that the value is 7. So let us see what those 7 indeterminacies are kinematically. So we will have a delta 1 here, a vertical deflection here called as delta 2. We can have a horizontal deflection here, delta 3. We can have a vertical deflection here as delta 4. We can have a horizontal delta 5 here, a vertical deflection here as delta 6, and a horizontal deflection here as delta 7. Okay, so there are 7 deflections which are possible in this figure. Out of these, the horizontal deflection at the point D, okay, delta 1, is asked. The reason why I am showing you this is that any of these other indeterminacies, kinematic indeterminacies, could also be asked in the problem. The procedure will remain the same. So let's see what is the procedure. The first step is to find the support reactions. So as we all know, here at the hinge support there will be two reactions. One will be vertical at E, and then we will have a horizontal reaction at E. And since at A we have a roller support, I will have a vertical reaction at A only. So let us start with the three equations of equilibrium. Summation of f of x is equals to 0. So if I do this, and let me take left side as positive. So if I do this, I will get that there is only one horizontal load, that is HE. So directly I can get that HE is equals to 0, right? Now next I can go for summation of moment about E is equals to 0. Summation of moment about E, and let me take clockwise moment as positive. All right, so let's come from left to right. So if you see, this VA will have a clockwise moment, right? So VA multiplied by 4 plus 4, because the perpendicular distance from the line of action of VA to E is this entire length AE, which is 4 plus 4, 8. So I can directly write VA into 8. Then here we have this 50 kilonewton acting in the downward direction. So therefore this will cause a negative, that is anti-clockwise moment. So minus 50 multiplied by 4 is equals to 0, or we can find this, that VA is equals to 25 kilonewton. Now, since this has come as positive, so therefore, we will have the chosen direction as correct. Our chosen direction for VA was upwards, so VA is equals to 25 kilonewton. Lastly, we can go for summation of F of Y is equals to 0. Summation of F of Y is equals to 0, and let me take this as upwards positive. So we will get that VA, already we know the value of VA is 25. So let's write that as 25. Then minus 50, the 50 kilonewton acting downwards, plus VE is equals to 0. Or VE will be is equals to plus 25. And since it is plus, therefore our chosen direction of upward is correct. Okay, so here we have got the support reactions. So now let's see what is our next step. Our next step is to find the member forces P due to the given loading using method of joints, and this is also called as the P analysis. And as you know, for the P analysis, we're using method of joints. First, we need to find out the support reactions, which is already found out. So I will just write the support reactions here. So vertical at E was 25 kilonewton. Students, note that you do not have to draw a separate figure here. In the figure that you have drawn, you can simply write this support reaction. So here also we will have another 25 kilonewton. All right, so the first step of the method of joints is done here. Now see, our next step is to find out the zero force members, that is the members that have zero forces. So you see here, if you examine the joint C, so here AC and CE are coplanar, right? And so therefore, and there are no loads acting at C, so therefore this force in the member CB will be 0. Okay, so I have identified this zero force member. Then if you examine this joint D, then at joint D there are two members meeting, DB and DE, and there are no forces acting at the point D. So therefore, by default, the force in the member DB and the force in the member DE will also become equal to 0. Okay, so I think these are the members where the forces will be equal to 0. Now let us choose the joint using which we will start the method of joints. But even before doing that, I suggest that we find out this angle BAC, angle BAC. Okay, so here let us find out this theta. What will be this theta? Now theta, if I can see, if I consider the right angle triangle DAE, so I can say tan theta will be DE divided by AE, or I can write that theta is equals to tan inverse, theta equals to tan inverse perpendicular by base. So DE is equals to 6 and the base is 4 plus 4, that is 8. So therefore the value of theta will be 36.86 degree. You can find this in the calculator. Okay, now let us start with a joint where there are two unknowns, where there are two unknown forces. So I can start with the joint A. So let me draw the free body diagram of joint A. Okay, so first let us draw the joint. This is the joint A. Okay, let me draw the known force, that is 25 kilonewton acting in the upward direction. And for the unknown forces, I always like to assume them as tensile, that is positive, and later if it comes as negative, then I make a remark that it is compressive. So this is FAC. See that I am making a FBD of this part. Okay, I'm making a FBD of this joint. So this part only I'll be considering. So the third member, that is, I mean, the next unknown that is there is FAB. FAB. And as we know that this angle here, we have already designated this angle as theta. Okay. Now you see, we have to apply only two equations of equilibrium, that is summation of fx and summation of f of y. So in order to do that, I must resolve this fab in the x and the y direction. So if I resolve fab in the horizontal direction, it will be fab cos theta, and in the upward direction here, this will be called as fab sin theta. Okay, so now let us start by using the equation of equilibrium, summation of f of y is equals to 0, and let us take the upward direction as positive. So what we will have here is fab sin theta plus 25 is equals to 0. Please note that while writing this equation, you have to only pay attention to the FBD that you have drawn. Okay, so this figure only you are supposed to see. Or FAB will be equal to minus 25 divided by sine theta. Right? So if you do this in the calc, you will get FAB is equals to minus 41.667 or 41.67 minus 41.67 kilonewton. And since this has come as negative, so I'll make the remark that FAB is equals to 41.67 kilonewton. This is compression because it has come as negative and we had assumed that this is positive. Okay, it's as simple as that. Now let us go for the second equation of equilibrium, that is summation of f of x is equals to 0. Let me take the right side as positive. Again, my focus should be on the free body diagram only. So I will have FAC plus FAB cos theta equals to 0, or FAC is equals to minus FAB cos theta. Now, please note that here FAB is known to us, but be very careful that here there will be a minus, which is this sign. Now, FAB itself is minus 41.67 cos 36.86. Be careful with this. So, it will give you that FAC is equals to plus 33.33 kilonewton. Now, since this is coming as plus, so therefore our chosen direction of tensile is correct. So quickly, I will write this in this diagram. Just see that FAB is in compression, FAC is in compression. So let me draw this as compression in FAB is in compression. So it will look something like this. value is 41.67. And here it's in tension. So this is how it will look like. And it is 33.33 kilonewton. All right, so now that our drawing is done, I have removed the calculations and now two members are remaining, that is CE and BE. CE and BE. So let us take a joint E so that directly we can find out both the values of member force EB and EC together. So I am again going to draw free body diagram of joint E. First, I will take the joint E. Then this known force of 25 kilonewton will be there acting in the upward direction. That is the support reaction that we had found out. Then this horizontal force, as you know, all unknown forces I take as tensile, I assume as tensile. Later automatically I find out FEC, and here I have FEB. FEB. Now see, this angle here, angle BEC, is also equal to theta. Okay, is also equal to theta. All right, so here let me call this angle as theta. So therefore, I will have to resolve FEB in the vertical direction and horizontal direction. So in the vertical direction, it will be FEB sine theta. And in the horizontal direction, it will be FEB cos theta. Now, let us start with summation of f of y is equals to 0, and let us assume the upward force is positive. Your focus should only be now on the FBD. So you see here, I have FEB sine theta in the upward direction plus 25 is equals to 0, or FEB is equals to minus 25 divided by sine theta. If you put the value of theta in the calculator, you will find that FEB is equals to minus 41.67 kilonewton. And what does this minus sign indicate? It indicates that our chosen direction, that is tensile, is wrong. So therefore FEB will be equal to 41.67 kilonewton compression, right? So now let us move on towards summation of f of x equals to 0. Let us consider left side as positive. Your focus should be on the free body diagram only. Since left side is positive, so FEC plus FEB cos theta is equals to 0, or FEC is equals to minus FEB cos theta is equals to, just see that now I'll be putting the values, minus FEB is already in minus. So let us take this as minus 41.67 cos 36.86 degree. So if you put this in the calculator, you will find that FEC is equals to 33.33 kilonewton, and since it is coming out as positive, so therefore it is tensile in nature. So let me represent that in the diagram. So here FEC is 33.33 tensile, and FEB is 41.67 compressive. All right, so here as you can see, the member forces of all the members of this truss is found out. All right, so now let us see the next step, that is step 3. What we have to do here is that to find the horizontal deflection at D, we have to remove the given loading. So as you can see here that in this figure, the given loading that is 50 kilonewton here has been removed, and instead of that we have to apply a unit load at D in the horizontal direction. So you see here 1 kilonewton has been applied in the horizontal direction. This is applied because horizontal deflection at D is asked. So horizontal force, horizontal unit load at D is applied. If the problem would have asked for vertical deflection at D, then we would have applied a vertical unit load at D. If the problem would have asked for a horizontal deflection at B, then we would have applied a horizontal 1 kilonewton at B. Now, your question may arise that whether to take this 1 kilonewton towards the left or towards the right, or towards the top or towards the bottom. It does not matter. What matters is horizontal or vertical. Horizontally, if you apply towards the left and you are getting your final answer as negative, that means the deflection is towards the right. And if you are getting positive, that means your deflection is towards the chosen direction, that is left. That is all. This is a assumed direction. You can take either to the left or to the right. Okay, so now with that, let us start by finding what is asked here. We have to find the support reaction. So again, you are knowing that since at A we have the roller support, so we will have the vertical at A here, and here we will have vertical at E and horizontal at E. So let us go for the equations of equilibrium. Summation of f of x is equals to 0, and let me consider the right side as positive. So here what I will have is plus HE minus 1 is equals to 0, or HE is equals to 1 kilonewton. And since this is coming as positive, so our chosen direction of right side is correct. Okay, next let us go for summation of a moment about E is equals to 0, and let me consider the clockwise direction as positive. So if I start from the extreme left, I will have a moment of VA multiplied by 8 in the clockwise direction. So that will be positive. And I will have a anti-clockwise moment of 1 into 6. So I will have to take that as minus 1 into 6 is equals to 0. Or VA will be equals to plus 0.75. And since this is plus, therefore our chosen direction of VA, that is upwards, is correct. Lastly, let us go for summation of f of y is equals to 0. And let me take the upward direction as positive. So here I will have VA in the positive direction. Already we know that the value of VA is 0.75. Okay. And we will have plus VE is equals to 0. Or we will get that VE is equals to minus 0.75. Now, what does this minus mean? It simply means that our chosen direction of VE is opposite to what its direction is. So therefore, let me write that 0.75 kilonewton will be in the downward direction, So you do not need to redraw the figure. Just see that in the next figure. Okay, I mean, for me it is the next figure, but for you it is the same figure. You simply change the direction of VE. So here what I will do is I will take VE in the downward direction. VE is 0.75 in the downward direction. Right. And here HA was in the right hand side 1 kilonewton. And VA vertical at A was 0.75 kilonewton in the upward direction. Okay. So in that figure only you can just make this change of VE. Now please note that we have come to step number 4, that is find the member forces U due to unit load using method of joints. Again, method of joints are to be used, and we can call this analysis as U analysis. So method of joints, you already know the first thing that needs to be done is to find out the support reactions. That is already found out. And the second thing is that here you have to also find out the zero force members. So if you see here, if you look at the point C, so you will get to see that AC and CE are coplanar and there are no loads acting at C. So therefore the member BC will be equal to 0. The force in member BC will be equal to 0. So this will be a zero force member. It will be a zero force member. But however, I cannot make any such comments about any other members here, because here at D now a load is acting, so I never know. There may be some load in BD and there may be some load in BE also. Okay, so let us start by taking the FBD of different joints where two members unknown forces are meeting and start finding out. Okay, so let me take FBD of joint A. FBD of joint A. First, let me draw the joint A as a circle here. Okay, then the known force 0.75 acting in the upward direction. Then let me take the horizontal member, that is AC, as outwards, so this will be FAC, and then we will have this FAB acting here like this. And as you know, we had determined that this angle will be called as theta. Now, since we have to find out the forces in the x and y direction only, so therefore we will have to resolve FAB. So if I have to resolve FAB in the horizontal direction, it will be FAB cos theta. And in the vertical direction, it will be FAB sin theta. Now your focus should be on the FBD only. Let's start with summation of f of y is equals to 0. And let me assume the vertical direction as positive. So what I will have here is FAB sin theta plus 0.75 is equals to 0, or FAB is equals to minus 0.75 divided by sine theta. Or if you put this right hand side in your calculator, you will find that force in the member AB is equals to minus 1.25 minus 1.25 kilonewton. This minus sign indicates that FAB is equals to 1.25 kilonewton, but our chosen direction of tension is wrong. It should be compression. Now next, let us go for summation of f of x is equals to 0. Summation of f of x is equals to 0. Let me take right side as positive. Let me take right side as positive. So here, you see, your focus should be on the FBD only. So here we will have FAC plus FAB cos theta is equals to 0, or FAC is equals to minus FAB cos theta. Please note that FAB itself is minus. So minus of minus 1.25 and theta is 36.86. So if you put this value in the calculator, you will get that FAC is equals to 1. FAC is equals to 1. And since this is coming as positive, so therefore it is tensile in nature. It is tensile in nature. So let us mark these two in the figure. This is tensile in nature, 1 kilonewton FAC. And this is compressive in nature. Okay, this is 1.25 kilonewton. All right, so now let us find the forces in the other members. Now see, I cannot now go for joint E because there are more than two unknown member forces attached to joint E. However, I can go for the free body diagram of joint B because there are only two unknown member forces here. But before I analyze that, I must find out the value of angle BDE. So let's call this angle as alpha. Okay, and we already know that this angle here is theta, right? So therefore, angle alpha must be equal to, we will take help of the property of the triangle that all angle summation of all angles of a triangle is 180 degree. So therefore let us take the angle sorry, triangle ADE. So therefore alpha will be 180 degree minus angle DEA, that is 90 degree, and minus angle DAE, that is equals to 36.86 degree. We have already found this out. So if you do this calculation, it comes out that alpha is equals to 53.14 degree. 53.14 degree. So now I am in a position to draw the free body diagram. Free body diagram of joint D. So let me first draw the joint, then the known force of 1 kilonewton towards the left, then the member force DE in the tensile direction, so FDE downwards, or should I say outwards, FDB again outwards, and this angle here is alpha. Now before going on any further, I will have to resolve this force as FDB. So FDB in the vertically downward direction, it is going to be FDB cos theta And here in the horizontal direction, sorry, not theta, here we are calling it as alpha. FBD cos alpha, and here also horizontally it will be FDB sin alpha. All right. Now your attention should be completely on the FBD of joint D. So let us start with summation of f of x is equals to 0, right? And let us take left hand side as positive. So what do we have here? We have here FDB sin theta FDB sin theta minus FDB sin theta plus 1, because we have taken left as positive, plus 1 is equals to 0. Again, I'm making a mistake here. FDB not theta, this will be FDB sin alpha. This is FDB sin alpha here. Or FDB is equals to minus 1 divided by sin alpha. Or you will get that FDB is equals to minus 1.25. Minus 1.25. Or what does this minus sign indicate? It simply indicates that FDB is compressive in nature. It is compressive in nature. So I will write simply that this is compression here. Now let us go for summation of f of y is equals to 0. You're focused entirely on the free body diagram. F of y is equals to 0. Let me take downwards as positive. So here I have FDE. I have FDE plus FDB cos alpha. FDB cos alpha is equals to 0. Or FDE is equals to minus FDB cos alpha. Now here let me put the values. So minus, and FDB itself is minus 1.25, and cos alpha, here cos alpha is 53.14. Alpha is 53.14 degree. So here if you find out, FDE will come out as positive 0.75, 0.75 positive, and that means that this is tensile in nature. So therefore let me go for writing here that this is positive tensile 0.75, and here FDB is compressive in nature 1.25 kilonewton. All right, so now we have two member forces left, EB and EC. So if we simply take this E here, right, we will get the value of both these members. So quickly let us draw the free body diagram of joint E. Free body diagram of joint E. So let me take this joint E. Right? The known force here 1 kilonewton towards this side. Then 0.75 in the downward direction. And 0.75 in the upward direction. Actually, we could have simply cancelled these two forces out, but okay, just let it be, we will figure out. Then we have a horizontal force here as FEC. Again, I am taking that as tensile. And here we have FEB, again tensile. Obviously, this angle is theta. Let us resolve the FEB. So FEB in the vertical direction here will be FEB sin theta, And here in the horizontal direction, it will be FEB cos theta. So let us take summation of f of y equals to 0, upwards is positive. And your entire focus should be on the FBD now. So in the upward direction, we have FEB sine theta plus 75, sorry, not plus 75, plus 0.75 plus 0.75 minus 0.75 is equals to 0. You don't need to solve this. These two gets cancelled. Hence, therefore, FEB will directly be equals to 0. FEB directly becomes equals to 0. Next, let's go for summation of Fx equals to 0. And let us take the left side as positive. So what we have here is FEC plus FEB cos theta. And here this 1 kilonewton is towards the right. So let me take that as minus 1 is equals to 0. Or, and since this term is equals to 0, so therefore FEC is equals to 1 kilonewton. Since this is coming as positive, so it will be tensile in nature. So quickly let me write this. FEB, we are getting it as 0, and this here is in tensile direction. This is equals to 1 kilonewton. So this ends our U analysis. Okay, so that brings us to our last step, step 5, that is find horizontal deflection at D using the unit load method formula. For this step, I'll be requiring this table, but let me first write down the unit load method formula, that is delta is equals to summation of PUL divided by AE. Now, P is the forces of all the members due to P analysis, U is the member forces due to U analysis, and L is the length of each member, and AE, as we all know from step number 1, is constant for all the members, so we are not bothered too much about it right now. We will input the value at the last. So let us try filling this table now member by member. So here I will write in the first column as member, then I will take P here, I will take U, I will take length in this, and finally I will do the multiplication P into U into L. Okay, so now we will have to go member by member. So let me write down the names of all the members. So for that I'll be taking help of this P analysis figure. So from here I can write the name of the members AB, BDDE, BDDE. Then let me write EC, AC and BC. And lastly, then we are left with BE, BE. Okay. So from this figure itself, I will write the, what do you say, the value of P. So here I will write minus 41.67 because this was compressive in nature. Then BD and DE, this member forces are 0 and 0. Then EC and AC, these two members are positive 33.33, positive 33.33, and again 33.33. Member force BC, BC is 0, member force BC is 0, and lastly BE is again minus 41.67, minus 41.67, right? Now for the U analysis. For the U analysis, already you have this table for the U analysis. So simply fetch the values from there. So I will have minus 1.25, minus 1.25. Right. Then I will have here, sorry. So here I have 0.75, that is positive 0.75 because it is in tension. Then I have at the bottom here, I have 1 and 1, so that is positive 1 and 1. And for BC, for the member BC, it is 0. Sorry. For the member BC here, it is 0, yes. And even for EB, it is 0. All right. So now the length of each member, this member AB, okay, this member AB, how much will be this length? Now, if you see by Pythagoras theorem, now see this entire thing is 6 meter. Let me go to laser mode. This entire thing is 6 meters. This thing is 6 meters. So by default, the half of this length here will be 3 meters. So here, sorry, 1 second. Yeah. So this member BC here will be 3 meters. It will be 3 meters. Right. This is 6 meter. This is halfway through. So therefore this will be 3 meter. Now, by Pythagoras theorem, if this is 4 meter, AC is 4 meter and CB is 3 meter, so definitely AB will be 5 meter. Okay. Similarly, BD will also be 5 meter. You can do this calculation. I'm not going to go too much into detail of this. And BE is also equal to 5 meter by Pythagoras theorem. Base is 4, height is 5. So therefore, the diagonal must be 5 meter. All right. So with this, we can write the lengths here. So this one here will be 5. Then again, this one here will be 5. Then DE is given, that is 6. This base members EC and CA, these are 4 and 4. And then again BC and BE, BC and yeah, so those are again, so BC is 3, right? And BE is 5. BE is 5. So let us do the multiplication now. Let us do the multiplication. So in PUL, right? In PUL, you have to do the multiplication of P multiplied by U multiplied by L. So I will just keep writing the values. 260.41. Since one term is 0, this entire thing becomes 0. This entire thing becomes 0. Then this here becomes 133.32. Here also this becomes 133.32. And again 0 and 0. Now you see, you will have to do the summation of PUL. You have to do the summation of PUL. So there are only 3 terms. Summation of PUL. Okay. So here only 3 terms: 260.41, 133.32 and 133.32. So from here you will get 527.05. 527.05. All right. So now let us find out the value of AE so that we can put it directly in the formula. So in your question itself, A is given as 800 mm square. Okay. And E is given as 2 into 10 raised to the power 5 MPa, megapascal. Megapascal is nothing but Newton per mm square. Okay. So if you put this in the calculator, you will get that it is 160 into 10 raised to the power 6. But see, it is 10 raised to the power 6. What am I writing? Yeah. So it is 10 raised to the power 6. And the unit will be Newton, because you see mm square and mm square get cancelled. Now you see all our other calculation is in kilonewton. So it is better that we convert it to kilonewton. So it will be 160 into 10 raised to the power 3 kilonewton. Okay, converting Newton to kilonewton, you have to divide it by 10 raised to the power 3. So here simply now I will put the formula, right? Summation of PUL is 527.05 divided by the value of AE is 160 into 10 raised to the power 3. Okay, so if I put this in the calci, I will get that 527.05 divided by 160. divided by 10 raised to the power 3. So answer I will get as 3.294 into 10 raised to the power minus 3. Now obviously this answer will be in meter, okay. So in order to convert it into millimeter, I can simply multiply it by 10 raised to the power 3, so that answer will be 3.294 millimeter. And since this has come as positive, therefore we can write our final answer, that is delta at D is equals to 3.294 mm, and our chosen direction of dummy force or 1 kilonewton was towards the left. So therefore this is your final answer because it is coming as positive. So that brings us to the end of this video. I hope this was useful for you. If you have any doubts, you can write it in the comments below. Thank you for your time.